Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to all of you. So for today, we will discuss our tutorial 3 and we have about 6 questions and let's have a look. Question number 1. Determine the horizontal and vertical components of reaction at pin A and the tension developed in cable BC. So cable BC, TBC. Pin, we have AX and AY. Okay. And the tension used to support the steel frame. So what do we have from the figure? We have our 60 kilonewton load, and we have another 30 kilonewton meter load. Okay, so for the free body diagram, our body AB, okay, this is body, okay, and what happened to our cable and pin? So this is our free body diagram, and this is the load, this is the load, and this is the cable, TBC, okay. And another support reaction at A is AX and AY. Okay, so in another way, for the clear version of the free body diagram, okay, so we have 60 kilonewton meter, we have 30 kilonewton meter, this is clockwise direction, we have tension TBC cable, this is 345, and we have another support reaction at A, AX and AY. Okay, now we need to solve our equation because our body is in equilibrium. So the equation of equilibrium is sigma fx equals to 0, fy equals to 0, and f moment equals to 0. Okay. So we need to break our force of TB. So we have actually force in X and Y direction. So we have here on X direction is TB times 3/5, and we have here TB 4/5. And there are no additional forces acting on the body with an angle. So we try to solve our equation. Okay. First one is Fx equals to 0, right, positive. And we have Ax positive minus B, TB, 3 over 5, x negative, okay? And that's it, equals to 0. We cannot solve the equation because we have Ax and TB. Now, Fy equals to 0. So from that, we have our Ay positive minus 60 kilonewton and also TB 4 over 5. TB 4 over 5 minus 60 kilonewton equals to 0. We cannot solve our equation. Okay, if we solve this one, we have how many unknowns that we have from the equations? We have three unknowns for two equations, which is ax, ay, and tb. So we cannot solve this problem. So another equation of equilibrium is sigma m equals to 0, counterclockwise positive. Which part of point that we want to put our moment fixed at point? So we put it at point A. Okay, so now for point A, at point A, so we have, if we fix at point A, we have for moment, okay, for moment we have TB 3 over 5 and the distance is here. So TB 3 over 5 and the distance is 3 meter and it is counterclockwise. Positive TB 3 over 5, distance 3 meter plus TB 4 over 5, distance is, so this is TB, this is the distance, 1 meter times 1 meter. And we have another 60 kilonewton. Because it is clockwise direction, 60 kilonewton meter times 1 meter the distance. And last one, we have 30 kilonewton meter x clockwise. Sorry. 30 kilonewton meter equals to 0. So for this equation, we have only one unknowns. So from this equation, we can solve our TB. So we have 9 over 5 TB plus 4 over 5 TB equals to 60 plus 30. Then 9 plus 4 is 13. So we have 13 over 5 TB. 13 over 5 TB. Bring it there, 5 over 13 times 90 equals to 34.62 kilonewton. So TB 34.62 kilonewton we use in our equation. So we have AX equals to 34.62 times 3 over 5. Got our AX is equals to 20.77 kilonewton. and another y is equals to 60 plus 34.62 times 4 over 5. So and we got 67.7 kilonewton. Okay, so we have solved our AX, AY, pin, okay, and also our cables, tension in the cables. Done. Sorry. Okay. Next question number 2. It is actually a kind of a tricky figure. Okay. Determine the normal reaction at A and B. At A and B, and the force link in link CD. Okay, this is our structure, and we have a free body diagram for the body ABC. This is one body. Okay, so this is our body that we want to look at. Okay, this is the body. Okay, and that is the body. And what is the force, load, and support reactions? So we have 2.5 kilonewton 60 degree, and we have also our moment 4 kilonewton meter acting at B. Okay. For smooth collar, we have normal 45 degree at A. And this is roller. So roller is normal to the B. And finally, we have our FCD. Okay. So that is our free body diagram. So we have this FCD, we have NB, and we have 4 kilonewton meter for 62.5 kilonewton, and this will at 45 degree normal to A. Okay, this is our free body diagram. So from this, our body is in equilibrium. So we need to solve sigma fx equals to 0, fy equals to 0, and moment equals to 0. Okay, we need to break the forces. This is at A, and A cosine 45 degree, and A sine 45 degree, 2.5 sine 60, 2.5 cosine 60, and that's it. Everything is in X and Y direction. Okay. First, free body diagram. Second, external load and support reactions. Third one, break it into X and Y direction. And fourth one, you need to solve your equation of equilibrium. So the equation of equilibrium, fx equals to 0. So fx equals to 0. Wait. Right. This one, okay, so fx equals to 0. That's okay. And a cosine 45 degree minus 2.5 cosine 60. Any x. Okay, so we have FCD. We have two unknowns, NA and FCD, so we cannot solve our equation. Fy equals to 0. We have positive of NA sine 45 minus 2.5 sine 60 from here to there, okay? So we have NA 2.5, we have NB, and that's it. It's equals to 0. So we have two unknowns, NA and NB. So we cannot solve the equation. If we join the equation for fx and fy, we have three unknowns, two equations, so we cannot solve our problem. So finally, we have m equals to 0. Which point of our body that we want to look at? This one is A, B, C. So we want to eliminate at least two unknowns. Okay, so if we take at A, let's have a look. If we take a moment at A, we will have two unknowns of NB and FCD. If we put at this line, this point, we will have three unknowns of NA, NB, and FCD. If we put at B, we have two unknowns of NA and also FCD. Okay? And if put at FCD at point C, we will have only one unknown, which is NA, because FCD is at the point and NB is on line with the point. So we have only one unknowns. We will put our point at C. Okay, so at C, sigma point at C, so moment at C equals to 0. So we have, if you put at C, this one is 4 meter. 6 meter and 3 meter. So it's 3 meter. Okay, sigma moment at C. So from point A, we have NA cosine 45 times 3 minus NA sine 45 times 10. Then we have 2.5 sine 60 times 6 minus 2.5 cosine 60 times 3 minus 4 moment. This is 4. Don't forget, equals to 0. Okay. From this one, you can solve that NA cosine 45 3 minus 10 NA sine 45 equals to 4 plus 2.5 cosine 60 times 3 minus 2.5 sine 60 times 6. Okay, so you can solve your NA is equals to blah blah divided by that thing. So you get your NA 1.059 kilometer. So you got your NA, and then you can use your NA here to get your NB, use your NA here to get your FCD. So we have FCD equals to 2.5 cosine 60 minus 1.059 cosine 45 degree. FCD is equals to 0.501 kilometer. Then NB is equals to 2.5 sine 60 minus 1.059 sine 45 degree. So NB is equals to 1.42 kilometer. We have solved our second tutorial. Okay, so we go to our next question. The jeep crane is supported by a pin at C and road AB. If the load has a mass of 2 megagram, okay, 2 megagram with its center of mass G, determine the horizontal and vertical components at the pin C, Cx, Cy, and the force developed in road AB, FAB, or we have a TAB, tension, on the crane when X equals to 5 meter. This is 5 meter. So, free body diagram. Okay, so our free body diagram will be this one. Tak nampak pula. Kalau terang sikit. Okay, so this is our free body diagram. This is our body. That is our body. And what do we have on the body? Which is external force and also support reaction. We have C is a pin, so we have CX, CY. We have 2 megagram here, 5 meter. W is equals to 2 megagram is equals to 2000 kilogram. If you want to calculate your weight is equals to mg, m is in kilogram. Do not change to gram. Okay, so 2000 times 9.81. So we have your weight. It's okay. We can put it in the equation later. So this is the weight. Don't solve it. You can also solve the equation and put it in the equation later, or you put all the value in the equation. Anything else that we have? So we have this one. Okay, T F A B. FAB is 3.2 and 4. It is actually, you have here 0.2. So actually, if you look at the first figure, okay, they have this one, 0.2. So it is from the center. So we want it to be here. Okay, so our FAB is this one, 3.2 minus 0.2. This is 4 meter and this is 5. Okay, so 3, 4, 5. So the free body diagram is 5 meter. 2000 times 9.81. Then 4 meter here. This actually here. And we have anything that I miss? That's all. Okay, so if your structure is in equilibrium, it need to satisfy equation of equilibrium where Fx equals to 0 positive, and we have Cx minus FAB for 5. That's it, equals to 0. So we have two unknowns, Cx and FAB, so we cannot solve. And we have our Fy equals to 0. And Fy, we have Cy positive plus FAB 3/5 minus times 9.81. Okay, then we want to find, because of this three unknowns, two equation we cannot solve, so we need our final equation, which is moment. So we put our moment counterclockwise positive at C. So if you put at C, we have FAB in y direction, FAB 3/5, distance is 4 meter, and we have FAB 4/5, distance is 0.2 meter, and we have clockwise direction of 2000 times 8.91, 9.81 times distance is 5 equals to 0. So from this one, we can solve our FAB equals to 2000 times 9.81 times 5 divided by 12/5 plus 0.8/5. Okay, so from that one we have okay, so we have 38 320 3832 kilonewton. So we put our FAB, so we can solve our CX. CX is equals to 38.32 times 4/5 30.6 30.656 kilonewton. CY, okay, you can solve your CY is equals to 19620 minus 38320 times 3/5 equals to minus 3.372 kilonewton. So CX is equals to 3.372 kilonewton to the left. So to the left positive. Sorry, the value is 3.372 kilonewton to the left. Solve our third equation. width. Okay, so we go to the question number 4. Determine the support reaction of roller A, roller A. Please carefully read here, roller A. So from A, it is a roller, not a pin. And smooth color B, on the road, it will react normal to your body. The collar is fixed to the road AB, so it is fixed, but it is allowed to slide along road CD. Okay, so the support reaction is normal to it. Right. So the free body diagram is like this. This is the body. Okay, this is our body. That is the body. And the second one, you need to draw the external load and support reaction. External load 900 Newton, external load 600 Newton meter, A and B, and support reaction, it is normal, which means this one is 45 degree. Okay, and then normal to A is this one. So we have an A and we have an C. Sorry, B. Okay. And now we have smooth collar, another type of load. Okay. We have moment B. Okay, then takut tak nampak, this one 600. Okay, and that's it. Our body, external load and support reaction. So again, we have to solve our fx equals to 0. So to right, positive. And we have for our fx is NB 45 NB 45 sit. So for x we have NB 45 minus NA equals to 0. So we cannot solve because it is two unknowns. And then Fy we have Fy and B sine 45 degree minus 900. That's it. Equals to 0. So we can solve our and B is equals to 900 divided by sine 45 equals to 1272.8 Newton, 1.27 kilonewton. So we have our NB. Now we can put our NB to find our NA. So here NA is equals to 1.27 time cos 45. It is equals to 1272. Okay, 900. 127 to 900 Newton. And NB. So we have solved NA and B. This one, moment at B. Moment at B equals to 0. So we have minus 900 times 1. Okay, this one. And then we have 600. Okay, we have 600 clockwise. And then we have NA. Okay, NA, I think our point B. So we need to find the distance here between the point. Okay, so we have 45 degree. This is 2 meter, and we need to find distance y. Okay, so y is equals to like this. So So we have this is opposite, adjacent, and hypotenuse. So we have O and H. So this should be the equation sine 45. So we have sine 45 equals to y over 2. Y is equals to 2 sine 45. So this is the distance for the moment. And now we have the positive because it is counterclockwise, NA. So we have NA is 900 Newton. and A times 2 sine 45 degree equals to 0. Sorry. I forgot to put it MB. MB is counterclockwise, so it is positive, and B equals to 0. So now we can solve our moment of B is equals to 227 Newton meter. We have solved our four. Okay. Next, have a look at question number 5. The S-stroke actuator at D, so this is S-stroke actuator at D is used to apply force F. So this is what we need to look at on the member at B. So this is F at B. This is the force. The normal reaction of the smooth shaft at C is 300 Newton. So the smooth shaft at C is this one, 300 Newton. And determine the magnitude of F, so sorry, F, and the horizontal and vertical component reaction at pin A. Okay, so free body diagram. So from the free body diagram, this is the body, and this is the diagram AX and AY at pin. So we have three unknowns, AX, AY, F. Okay. Okay. Now, I just put it. Put it up there. Boleh. Okay. So nanti kenapa dia tak boleh ke tepi? Okay, tak apalah. Nanti kita nak tengok. Okay. Alright. So we have the equation and AX, AY, and at F we have F sine 60, and this one is F cosine 60. We have F, AX, AY, and we have 300 Newton, which is this one. Singgit. Okay. 300 cosine 15, and this one 300 sine 15. Okay, to solve the equation, we have fx equals to 0, and we have ax plus 300 cos 15 minus f cos 60. We cannot solve because we have two unknowns of ax and f. Next, we have fy equals to 0. So we have ay minus 300 sine 55, 15, not 55, plus f sine 60 equals to 0. We cannot solve because we have ay and f. Okay, we want to find the moment. Okay, so moment, we take moment counterclockwise at a. Okay, moment counterclockwise at point A. Moment counterclockwise at point A. So we have this load acting counterclockwise. We have F sine 60 times 800 millimeter. Okay, 800 millimeter. And we have our force of 300 Newton. Okay, so 300 Newton, this is what we need to look at. It must be perpendicular. Okay, so from that one, we need to find the distance. Okay, so the distance is, this one is 600. Okay, this one is 600. And then we need to find this one. So look at here. So we have okay, sedikit sikit lah. We have this. So what we need to know is this one. And we have here is $200. This one is 15 degree. So we need to find this A. A is So, okay, sine 15 degree opposite over hypotenuse. Sine 15 equals to A over 200. A is equals to 200 sine 15. But the distance for our 300 Newton is this 600 plus 200 sine 15. Okay, and it is rotate clockwise direction. So we have 300, this is minus 300 times 600, the distance, plus 200 sine 15 degree equals to 0. So from this equation, you can find your F. F is equals to 282.22 Newton. And then you can solve your AY is equals to 300 sine 15 degree minus 282.22 sine 60 degree, and AX is 282.22 cos 60 degree minus 300 cos 15 degree. Okay, so we solve 282.22 cos 60 minus 300 cos 15. It is AX is negative 148.6.7 Newton. AY is equals to negative 166.8 Newton. Okay, so from that one, we have our AX is equals to 148.7 Newton to the left, and AY is equals to 166.8 Newton down. Okay, so this one we have the positive value, that one. So we have find our AX, AY, and F. So 148.7, 166.8, 282.22 Newton. Right? So the trickiest is at the distance for our 300 Newton. Okay, right. For question number 6, I give it to you to prove the uniform road has a length L and width W. L and W. It is supported at one end by a smooth wall. So for the smooth wall, this is an A. Okay, and then we have our cables by a cord. So this is another TBC or FBC, okay, which is attached to the wall as shown. Show that for equilibrium, it is required that H equals to that one. Okay, so the step is you need to find the moment, and then from this one you will get TBC equals to blah 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 in W form. In W, because no given weight of our rod. Okay, so it is in W form, and then you need to find your Fy. Okay, then from the triangle, you need to use sine law. Okay, and sine law using theta here. Sorry. Theta, and this is 180 minus theta. This is theta minus phi, and this is phi. Okay, using sine law, and then you need to use cosine law. Cosine law A square equals to B square plus C square minus 2BC cosine A. All right, so from that you can have your equation, and you can solve the equation. Okay, and it must be comply with this one. The final answer is that one. H is equals to in S form. Dalam sebutan S. Okay, so I hope that you will try how to prove this problem, and I hope that you can get the answer. This is the answer, so just prove it using your knowledge of cosine and sine law. Okay, that's it. Thank you very much. See you in another class, next class. Hope you have um, a good day for today. Thank you very much. Bye.